Welcome to the Deep Dive. This is where we take your sources, articles, research, even our own notes, and, well, we pull out the key insights for you. Today we're getting into something pretty fundamental in the cloud-native world, Kubernetes deployments. Our mission really is to unpack how these deployments act as that crucial blueprint, let's say, for running and updating your applications reliably, automatically. Basically a shortcut to understanding a core concept. And we're drawing from excerpts from Kubernetes deployments, declarative management, and updates. So we hear deployments thrown around a lot with Kubernetes. Can you help us really pin down what its main job is? What problem is it solving?
Absolutely. So at its heart, a deployment is a Kubernetes resource. Its job is managing a set of identical pods. Think of it maybe less like just a blueprint and more like, the intelligent foreman on a job site.
Okay, the foreman.
Yeah, you give it the plans. That's your application's desired state, and it makes sure those plans are built, yes, but also maintained, scaled, updated, exactly like you specified. It's mostly used for stateless apps, things like web servers, APIs, making sure you always have the right number of pod replicas running, and this is key handling updates without any downtime.
Right, so it's not just starting it, it's keeping it going. Resilience.
Exactly.
Given that, why are deployments just so central to, well, how we do things in Kubernetes? What big problems do they solve?
Well, it's interesting because deployments tackle several really big challenges that developers and ops teams have wrestled with for ages. First off, reliability. They make sure your app stays available. Pod crashes, node goes down. The deployment sees that and replaces the pod automatically, keeps that desired count.
Okay, that's huge.
Then scalability. Need more instances for a traffic spike, or if you were to save costs, you just change one number. Super simple. Third, seamless updates. Remember, updating apps used to mean downtime or these really complex manual dances.
Oh, yeah. Fingers crossed.
Yeah, right. Deployments bring in things like rolling updates. Zero downtime deployments become, well, standard. And finally, the whole philosophy behind it, declarative management. This really changes how you interact with your infrastructure. You say what you want.
Not how to get there.
Exactly. Kubernetes figures out the how.
That declarative part sounds really powerful. And it feels like deployments don't work in a vacuum, right? They lean on other Kubernetes bits. Can you quickly walk us through those basic pieces, just for context?
Sure. So the smallest thing you can deploy is a pod. That's where your application container or containers actually live. Now, deployments don't manage pods directly. They use another controller called a replica set to make sure you have the right number of identical pods.
Okay, replica set handles the counting.
Pretty much. And all this happens inside a cluster that's your set of machines, nodes, managed by Kubernetes. You, the user, mostly interact using kubectl. That's the command line tool. And processing everything, keeping track of the state, that's the API server. It's like the brain or front desk of the control plane. Honestly, for anyone starting with Kubernetes, getting deployments is like step one for solid automated app management.
Okay, let's unpack this declarative model a bit more. You said it changes how we interact.
Yeah.
What does that really mean day to day for someone managing apps, beyond just, define the desired state?
Well, it's a pretty big shift in mindset, actually. Instead of writing a script step by step, create pod A, create service B.
Yeah, the imperative way.
Right. You just give Kubernetes a YAML file, and that file declares, I want 3 replicas of this web server running using this image open on this port. You're not telling it the steps. You're defining the end result.
And Kubernetes takes from there?
Completely. It takes responsibility for reaching that state and, crucially, maintaining it. Always watching, always adjusting. It shifts your focus from, micromanaging the infrastructure
to just saying what you need.
Exactly. Think about the mental energy saved, the potential errors avoided. It lets engineers focus more on the actual application code.
That difference between orchestrating and declaring feels really important. Okay, we've got the what and why. But how does this, elegant idea actually work inside Kubernetes? What's the flow?
Yeah, it's a neat process. It brings together a lot of those components we mentioned. First, you define the desired state. You write that YAML file replicas, container image, update strategy, all that.
Got it. The YAML file.
Then you submit it to the cluster, usually with kubectl apply. That YAML config goes straight to the API server.
The front door.
Right. The API server validates it and stores it persistently and etc. That's Kubernetes distributed key value store. Think of etc. as the cluster's single source of truth, its memory. Okay, now Kubernetes enforcement begins. There's a process running called the deployment controller. It's always watching etc. for deployments. When it sees yours, it reads the desired state. Then it works with the replica set controller. The replica set makes sure the right number of pods exist to match the spec. Then the scheduler figures out which nodes are best suited to run those pods. And finally, the kubelet, that's the agent on each node, actually starts your containers.
Wow, okay. Quite a chain of events.
It is. And the last piece is automatic adjustments. The deployment controller doesn't just set things up, it constantly monitors. If a pod dies or gets deleted, or if you change the replica count,
It fixes it.
it jumps in automatically, creates or removes pods to get back to that desired state you defined. You declare it once, Kubernetes makes it so, continuously.
That constant loop is amazing. And the YAML file is central. Can you give us a bit more detail on what's in that file? What are the key sections?
Sure, when you open up a deployment YAML, you'll see a few key fields. There's a HUP version and kind. That just tells Kubernetes what kind of object this is, like apps v1.
Use the nerd stuff.
Yeah. Then metadata. That's where you put the deployment's name, maybe some labels so you can find and organize things easily. But the real action is in the spec section.
Okay.
Inside spec, you'll definitely see replicas. That's the number of identical pods you want running. Then there's the selector. This is super important. It tells the deployment which pods it's supposed to manage based on matching labels. It's how it recognizes its children, basically.
Gotcha. It connects the deployment to the pods.
Exactly. Then you have the template. This is literally the blueprint for the pods themselves. It specifies the containers, the Docker image to use, ports to open, environment variables, everything the pod needs. And finally, often there's a strategy section. This defines how updates should be handled, like that rolling update we talked about.
Right.
So a simple example, the spec might say replicas. 3, use the nginx.latest image in the template, and Kubernetes just makes sure 3 nginx pods are always up and running. If one crashes, it restarts it or makes a new one.
Okay, so pulling this all together for someone listening, what are the big practical wins of using this declarative model? How does it change their day-to-day?
The wins are pretty significant. First, simplicity. You're just describing the what, not the how. That means less complex scripting, fewer chances for manual mistakes.
Less busy work.
Definitely. Second, consistency. Your cluster state should always reflect what's in your YAML. This cuts down on configuration drift, makes troubleshooting way easier. You know what should be running. Third, huge automation. Kubernetes handles creating pods, scaling them, recovering from failures. Think of the manual toil that eliminates.
Yeah, that's a lot of saved effort.
And fourth, because it's all text files YAML, you get great version control. You can store your infrastructure configuration in Git right alongside your application code.
Infrastructure as code.
Exactly. That's huge for collaboration, tracking changes, rolling back mistakes, audits. It's a really powerful way to manage infrastructure.
That automation piece sounds especially useful for updates. Rolling out new features, fixes. I remember the bad old days. Painful downtime, crossed fingers. The source material says deployments excel at managing application updates. How do they make it so smooth? Avoid those old outages.
Yeah, they really do excel there,
Huh.
mostly through the default rolling update strategy. What this means is when you update your deployment, say, point it to a new container image, Kubernetes doesn't just kill all the old pods and start new ones. That would cause downtime.
Right.
Instead, it does it gradually. It starts creating new pods with the updated configuration while the old ones are still serving traffic. Then, as the new pods become ready, it starts terminating the old ones. It's a controlled handover.
So there's always something running.
Exactly. Continuous availability. You can even control the pace with parameters like max urgent, how many extra pods it's okay to have temporarily.
Yep.
And max unavailable, the maximum number of pods that are allowed to be down during the update, gives you fine-grained control.
That's way better than the old all-or-nothing approach. So how does that work step by step? It sounds like a carefully managed process.
It is. It's quite orchestrated. First, you update the deployment YAML. Maybe you change the image tag in the pod template to your new version.
Simple change in the file.
Right. Then you apply the changes using kubectl apply. That tells the API server about your new desired state. The deployment controller sees this change. It then creates a new replica set specifically for this updated version. And here's the rolling part. It starts scaling up the new replica set, creating new pods, and simultaneously scaling down the old replica set, terminating old pods.
The handover.
Precisely. Kubernetes gradually replaces the old pods with new ones, making sure it respects those max surge and max unavailable settings, and keeps the total number of available pods close to your desired replica count. And all through this, the deployment controller is monitoring the health of the new pods. It waits for them to be ready before continuing the rollout.
Okay, that sounds robust. But, what if things go wrong? New version has a bug, starts crashing, performance tanks. What then?
That's where rollbacks are just invaluable. It's a critical safety net. See, Kubernetes keeps a history of the changes you've made to your deployment. These revisions are stored in, etc.
So it remembers the old versions.
It does. So if you deploy a new version and realize, uh-oh, this is bad, you can simply tell Kubernetes to roll back to a previous known good revision.
How does that work?
You use a kubectl command, basically saying undo the last rollout or go back to revision number X. The deployment controller then handles the seamless recovery. It essentially performs another rolling update, but this time it scales down the bad replica set and scales up the replica set corresponding to the good previous revision.
So it rolls forward to
Ah,
the past state.
kind of, yeah.
Hmm.
It replaces the faulty pods with instances of the previous stable version. It's incredibly useful for quickly recovering from bad deployments.
That's a fantastic overview. We've really dug into how Kubernetes deployments offer this declarative way to manage stateless apps. It delivers that reliability, the easy scaling, those smooth, zero downtime updates we talked about. You just define your desired state in YAML, and Kubernetes automation takes over, maintaining replicas, handling updates, even rollbacks. It really feels like a cornerstone technology.
Absolutely. And building on that, this whole powerful declarative approach, it makes you wonder, doesn't it? How might this fundamentally change how teams think about, well, not just deployments, but maybe the entire life cycle, application development, operations, the whole pipeline? What if everything worked this way?
That is definitely something to think about. A great final thought. Thank you for joining us for this deep dive.